Hello, I'm Laura Marshall.
And I'm Melinda Rhodes, and this is Light Matters for October 23rd, 2013.
On today's show, a new coating tricks infrared cameras, Raman scattering gains speed for use in microscopy, and we mark Manufacturing Month with a visit to Trumpf.
A new coating that looks cooler when it's heated allows it to hide from infrared cameras. Applied physicists at Harvard placed the device on a hot plate and watched it through an infrared camera as the temperature rose. Initially, it behaved as expected, giving off more infrared light as it got hotter. But when it hit 74 degrees Celsius, something strange happened. The thermal radiation plummeted. At 80 degrees, it looked blue as if it could have been 60 degrees, and at 85 degrees, it looked even colder. And the effect was reversible and repeatable. Principal investigator Federico Capazzo predicts that with only small adjustments, the coating could be used as a new type of thermal camouflage or as a kind of encrypted beacon to allow soldiers to covertly communicate their locations in the field. The secret behind the material is a very thin film of vanadium oxide, an unusual material that undergoes dramatic electronic changes as it reaches a particular temperature. The team suggests that the material could be engineered to operate at specific wavelengths, enabling simultaneous use by many individually identifiable soldiers. The Harvard team's most significant contribution is the discovery that nanoscale structures that appear naturally in the transition region of vanadium oxide can be used to provide a special level of tunability, which can be used to suppress thermal radiation as the temperature rises. The results appear in the open access journal Physical Review X.
Improvements to Raman spectroscopy using laser frequency combs allow multiple signals from different parts of a molecule, or even different molecules, to be monitored simultaneously with a single detector. The advance is seen as a major step toward the holy grail of real-time, label-free biomolecular imaging. For decades, biologists have attached fluorescent dye labels to certain proteins to distinguish them under a microscope. But such labels can alter the cell's function. For label-free imaging, biologists use coherent Raman spectroscopy, which obtains chemical and structural information about molecules by analyzing how laser light is scattered by a sample. Because the technique uses near-infrared or visible lasers, it offers high spatial resolution and 3D sectioning capability. But scanning Raman microscopes focus mostly on a distinct spectral feature of a selected molecule, so they can provide images quite rapidly. To analyze a complex mixture of molecules, a complete Raman spectrum must be recorded for each image pixel, something existing techniques are too slow to do. That's where the frequency comb comes in. A team at the Laser Spectroscopy Division of the Max Planck Institute of Quantum Optics showed that these combs, which are lasers that produce a train of ultrashort pulses at a highly precise rate, can speed up impulsive Raman scattering to enable measurement on the microsecond timescale, which is fast enough to be used for microscopy. The ability to use microscopy in this way could help explain how a drug influences a living cell or how single molecules alter cell metabolism. A paper on the project appears in Nature.
October is being celebrated here in the U.S. as Manufacturing Month. We were invited recently by laser maker Trumpf in nearby Farmington, Connecticut, to join some tours they were giving to students from local high schools and Springfield Technical Community College's Lasers and Optics program. I spoke with Annette Doyle, manager of Trumpf's machine assembly, about what lean manufacturing is and its importance to laser manufacturing.
Yeah. Lean manufacturing, put very easily, is the elimination of all waste that you have in your processes and your daily activities. So very concretely, this means usually looking at a certain process as a big process, a small process, and dividing everything that happens into value add and non-value added activity, eliminating what is non-value added, and thus making the same product with the same quality or better quality at a cheaper price. One of the ways that you're trying to avoid or eliminate is setup times for a machine. So if you have a machine with a physical tool, you need to change it every time you make a different part. The laser is an incredibly flexible tool. If you need to change the contour of your part, you type in 3 numbers in there. If you need to change the thickness of your part, you type in 3 other numbers. And you can very quickly change over. So you basically have no setup times with the laser. That's one of the big areas where the laser can help to achieve lean manufacturing.
And what suggestions do you have for someone who wants to get started in lean manufacturing?
My tip is always, I call it the 3 Ps that you need to look at. And that's your people, your processes, and your product. As a manager, go out there into the production line, talk to the people, and more importantly, listen to the people. What is holding them up from performing their job in the most efficient way? Watch the people, watch the processes, and watch the product as it goes through your line. And if you do that for a half an hour every day, you can take improvement work away for years to come.
Oh, that's really interesting. I know that Trumpf has facilities all over the world. Can you tell us what kind of lasers they make in Farmington?
Their flagship product is the 2D laser cutting machine, the TrueLaser 1030. Both the lasers and the entire machines are manufactured in Farmington.
Great. Did the kids on the tour seem interested in manufacturing?
Definitely the Lasers and Optics group at Springfield Technical Community College. You heard Annette earlier talk about the 3 Ps, and she also talked about the importance of doing these tours with kids to talk about the 3 Ds, which are that manufacturing is not dark, dirty, or dangerous like people maybe think back to 100 years ago, and that manufacturing is a great job to get into. It's a nice steady work for people who are in high school to consider. So she wanted to make that point, and definitely going on the tour, we saw that the facility is very sophisticated and clean, and the students from Springfield Technical Community College brought some of their resumes, and in that group there were some fans of Photonics Spectra who had read a feature I wrote a couple of years ago about lasers and manufacturing.
Oh, that's great. It's always fun to meet some of our readers, interact with them, get some feedback.
Absolutely. Well, that's it for this edition of Light Matters, the Photonics Industry's only weekly newscast.
As always, you can write to us with your comments or questions at lightmatters@photonics.com.
Thanks for watching, and we'll see you next week.